Bismillahirrahmanirrahim. Dear students, I hope you all are in good health. Today I'm going to discuss the second topic, which is basically the first main topic of our first chapter, which is about Coulomb's law. Okay, Charles Coulomb, he was a French scientist, and in 1874 he performed a number of experiments to measure the force between two electric point charges, and he stated his experimental observations in the form of a statement which is known as Coulomb's law. And this law states that the magnitude of an electrostatic force between two point charges is directly proportional to the product of the magnitude of the charge and inversely proportional to the square of the distance between them. So if you are talking about the mathematical form of Coulomb's law, so I have derived the mathematical form of Coulomb's law for you, and I hope it will be helpful for you people. Let us consider, or if there are 2 point charges q1 and q2, and they are separated by a distance r, as I have shown here in this diagram, then the electrostatic force, the F, the force between these two charges, whether it is attractive force or whether it is repulsive force, so that force can be given by, first thing, according to the law, that the force is directly proportional, yeah, the magnitude of the electrostatic force is directly proportional to the product of the magnitudes of the charges. So F directly proportional to q1 q2, so product of these two charges, let's say this is equation number 1. Then F inversely proportional to square of the distance between them, so F inversely proportional to r square, let's say this is equation number 2. Now combining equation 1 and 2, so just combine these two equations, we can get F proportional to q1 q2 divided by r square, and then F is equal to k q1 q2 divided by r square. Just look here, this k, let's say this is equation number 3, but what is this k? Here F is the magnitude of the mutual forces, this F, and this k is the constant of proportionality, and it is known as Coulomb's constant. It is known as Coulomb's constant, and this k depends on two things: one, nature of the medium between the two charges, and the system of the unit in which F means the force, charge, and the distance are measured. So if F is measured, yeah, the force is measured in Newton, q1 and q2, the charges are measured in coulombs, and the distance is measured in meters, and the medium between the two charges is free space, then the value of k will be 1 divided by 4 pi epsilon naught. So from here the mathematical value of k, you can get k is equal to 9 multiplied 10 raised to the power 9 Newton square meter per coulomb square. Okay, so thus the Coulomb's electrostatic force in free space, from the previous equation we can get, you can just put the value of k in that equation, in the previous equation, F is equal to, which become F is equal to 1 divided by 4 pi epsilon naught q1 q2 divided by r square. So this is the magnitude of the force between two charges in free space. So as we know that the force is a vector quantity, therefore its direction should also be shown, so which I will discuss in the next video.